Hi there. Up until this point, we've been looking at examples where you have several tasks going on in parallel, but sometimes you just want to process a chunk of data by splitting it into different parts and then processing those parts in separate threads. So essentially you want a parallel version of a for and ForEach loop, and it just so happens that .NET has this functionality. So what we're going to take a look at in this section is the following. First of all, we'll take a look at Parallel Invoke, Parallel For, and Parallel ForEach. We'll take a look at the options that you can customize these loops with. We can take a look at how to do a stepped for loop, because it just so happens that the for loop just does a step of one. Then we're going to take a look at the typical stuff related to concurrent execution, namely how to stop a parallel loop, how to cancel it, how to throw exceptions, and what happens when you throw exceptions out of a parallel loop. And then we'll talk about something called thread local storage, which is an optimization technique that you can use to speed up the actual calculations that you do in loops. And finally, we'll talk about partitioning, which is the process of separating your original data set for multi-threading. We'll take a look at how custom partitioning settings can actually improve the execution time compared to the defaults. Now is the time to get ourselves acquainted with parallel loops. What are they for? Well, the idea is actually very simple. If you think of a bunch of tasks that you have to process in a typical for loop, let's say going from 0 to 100, there are situations where it's actually possible to do those things concurrently. For example, if you have 100 values, so you have int values equals new int 100, let's suppose you want to do something with them, say calculate the square of each one of them. Those operations are actually independent, and the end result is that you can take this loop and you can parallelize it. But the question is how? And this is where the task parallel library comes in, because it gives you the functionality for parallelizing the for and ForEach loops. So let's take a look at what is in store. We are going to be using a class called Parallel. And this class has just three methods, as you can see: ForEach, and Invoke. We're actually going to start with Invoke because it's also one of the things worth mentioning. So what Parallel Invoke does is it basically takes the functions that you want to run and runs them concurrently. You can see that it simply takes a params action here. So what we can do is we can make a couple of actions, just a new action, which does something. I'll stick a lambda in here. Let's actually write line the information about this function. So for example, I can say this is the function first, and in addition I'll get the task ID here. And yes, this functionality does make use of tasks as well. So I'll put B and C in here, and we'll have second and third. And what Parallel Invoke lets you do is it lets you run these three actions concurrently. So you can say something like parallel.invoke, just A, B, C, and execute. Now here is the output. You can see that there are different task IDs associated with the action, so they're all happening on their own separate threads, and this is simply a utility. So essentially what's happening is you make a task out of each action and then you do a wait. All of the operations on Parallel, whether it's Invoke or Parallel ForEach, they are blocking. They're like doing a wait on each of the items that you're processing. So let's take a look at the Parallel For loop. So let's say I want to do something with numbers from 1 to 10 inclusive. In this case, I have to do the following. I have to say parallel.for, and first of all I specify the starting value. Notice the starting value is inclusive, so I'll put a 1 in here. Now if I want to count up to 10, I need to put an 11 in here, because the upper bound is exclusive, which means it excludes 11. It's going to have everything that's less than 11. So the final argument is a function that you want to operate on each of the elements. This function happens to take the argument. In this case, we're looping through integers, so we're going to take the argument I and we're going to do something on it. In this case, all I'm going to do is output the square of the number. So I'm going to say I times I, like so, and let's put a tab in here. Okay, so this is, once again, lots of things happening here. So we start all of these threads and then we wait on all of them automatically. So as soon as you write parallel for, it's not that these are scheduled to run in the future time. When you call start, they run immediately. So as I execute this, you can see that I'm getting my squares. I'm not getting them in order. You can see that I'm getting 1, 4, 16, 36, 64, 100. And then somewhere else, I'm getting 81, 49, 25, and 9. So you can't expect them to execute in a specific order because it's all happening at the same time. So we have parallel invoke, we have parallel for, and the third part is parallel for each. Let me show you that. So let's suppose we have a bunch of words. So I'm going to have O, what, a, and night. And let's suppose that I want in parallel to output, for example, the length of each word. What I can do is I can say parallel.forEach. And in this case, instead of having a counter starting at 1 and ending at 11, I will simply provide the IEnumerable. So I can take words and I can stick it in here. And then once again, I can provide the lambda. So for each word, I can provide a function which is going to process this word. And here we can simply write line. Let's actually output a bit more information. So here I'm going to say that the word has length, and then provide word.length. And in addition, I'm going to also write the number of the task just so you can see what's going on. So I'm going to say task.currentID, like so. Okay, so we have this code for running things in parallel on the words. Let's actually execute, and we can see O has length 2. And it's task 12, this is task 13, this is task 15, task 14. So there are differences here in terms of how long each task took. You can see that 15 came earlier than 14, surprisingly enough. So this is how you would operate on just a sequence of elements, essentially. Now, one thing worth mentioning with regards to parallel for is the step for each of the I variables is always 1. It goes from 1 to 2 to 3 to 4, and that can be a bit of a problem if you want to have maybe stepping over the even elements or having a custom step size. So in this case, what you have to do is you have to revert to parallel for each. So essentially, if you want to have a step of some kind, you need to define your own function. We can define some static function which returns an IEnumerable of int. Let's call it range. So range is going to take the starting value, the end value, and it's also going to take the step. And then what we can do is we can simply yield the elements as they kind of show up. Let's see what the problem is here. Oh yeah, we need a return statement. We'll get one in a moment. So essentially the idea is you make a for loop which starts at the start argument, ends at the end argument, and the increment is not plus plus, instead it's increased by the step. So here we can yield return the value I, and what this means is that you can now write a parallel for each loop which acts as a parallel for but with a custom step. So for example, I can do something like the following. I can say that for instance, parallel dot for each, I can make a range starting at 1 ending at 20 with a step of 3, and for each of the values I can just write line the value to the console, like so. Let me get rid of all of this. So let's see what we get. In this case, we're getting 1, 4, 16. That's our squares. And then we're getting, you'll see it here. Actually, let's actually get rid of the previous output so it's a bit more clear what we're getting. So it's 1, 7, 19, 4. Once again, you can't expect them to be in order, but we do have the custom step. So it's 1 to 4 to 7 to 10. So a step of 3 each time. So that's the overview, if you like, of the parallel loops and what you can do with them. Let's also take a look briefly at the options that you can provide into a parallel for or for each. There is an argument here specifically for parallel options. Let's do that. So var PO equals new parallel options. Now, there isn't much in parallel options. You can provide a cancellation token for canceling a particular parallel loop. You can also specify a maximum degree of parallelism, basically specifying how many tasks can be running at the same time. And finally, you can provide your own custom task scheduler if you want to.